Dear viewers, I hope everyone is doing well. And today the concept is drawing the PV and TS diagram for the Carnot cycle. So no need to by heart. Logically, if you can learn, the remaining cycles will be very easy. So in thermodynamics, we have various air standard cycles, Otto cycle, diesel cycle, dual cycle, and Atkinson cycle. So many cycles we have. So similarly the Carnot cycle. Out of all the air standard cycles, the Carnot cycle, the efficiency is high. So today we will learn drawing the PV and TS diagram for the Carnot cycle. In the subsequent classes, we will focus on to the remaining cycles. So the Carnot cycle, the PV and TS diagrams. So first we will learn the process used in the Carnot cycle. Any cycle, either it may be the Otto cycle, diesel cycle or dual cycle. Any cycle, the series of process are same. So in the power plants, we have four components. The first one is the boiler. The second one is the turbine. The third one is the condenser. And the fourth one is the pump. So the working fluid is water that passes through all the process and the power will be produced. So in the boiler, the heat is added. So the process is called the heat addition. The process occurred in the boiler is called the heat addition. In the turbine, expansion occurs. So the steam that passes through the turbine, the expansion occurs, the power is produced. So the operation occurred in the turbine is the expansion. Further, so the working fluid, expanded steam that passes through the condenser. In the condenser, the heat rejection occurs. So the operation occurred in the condenser is the heat rejection. Similarly, later the working fluid, it passes through the pump and the pressure will be increased. So that is called the compression. So the compression occurs in the pump. So the series of operations are heat addition, expansion, heat rejection, compression. These are common in all cycles. Suppose if it is the Carnot cycle, the heat addition is occurred isothermally. So the isothermal heat addition. The process in the boiler is the isothermal heat addition if it is a Carnot cycle. Later, the expansion occurs, the thermodynamic operation is isentropic process. So keeping entropy constant, the expansion occurs. So the second operation in the Carnot cycle is the isentropic expansion. Later, the heat rejection. Similar to the heat addition, the heat rejection is also maintained at constant temperature. It is called the isothermal heat rejection. So the pump, later the compression occurs thermodynamically. The operation in for the compression is isentropic. So isentropic expansion, isentropic compression. Constant temperature heat addition, constant temperature heat rejection. So these are the sequence of operations in the Carnot cycle. So how can we remember the Carnot cycle? It is very easy. So here you can see the TS, isothermal heat addition, isentropic expansion, isothermal heat rejection, isentropic compression. So the cycle can be remembered as TS. So we can give the code for the Carnot cycle, the TS. Like that we can remember the Carnot cycle. So the sequence operations are these. So we can start from any operation. So I will start from here. So 1 to 2 is the isothermal heat addition and 2 to 3 is the isentropic expansion. 3 to 4 is the constant temperature heat rejection and the 4 to 1 is isentropic compression. So these are the sequence of operations in the Carnot cycle. So for this we will practice drawing the PV diagram and also the TS diagram. The PV diagram and the TS diagram. So first we will practice the TS diagram and afterwards we will come for the PV diagram. So drawing the TS diagram is very simple. So this TS diagram, the coordinate axes are shown. The temperature is taken on the y-axis, the entropy is taken on the x-axis. So the first one is the isothermal heat addition. So keeping temperature constant, the heat will be added. So keeping temperature constant. So on the TS diagram, constant temperature is horizontal. Constant entropy is vertical. Other than this, the remaining are the curved lines. That is the main concept, the basic concept for drawing the TS diagram. Temperatures are constant, horizontal. Entropy is constant, vertical. The remaining are all the curved lines. So here, if you see the process 1 to 2, that is the isothermal heat addition. Isothermal temperature is constant. So the temperature is constant. So that has to be drawn horizontal. Whether horizontal forward or horizontal backward. Whether the horizontal forward or horizontal backward. So you can see isothermal heat addition. Due to the heat addition, the entropy increases. Therefore, you have to draw horizontal and forward. So 1 to 2 is the heat addition. The heat addition is the isothermal heat addition. The isothermal heat addition. So immediately after the process, if you mention the name, you will not make any mistake. So 1 to 2 is the heat addition. The heat addition is shown on the TS diagram. Later, 2 to 3 is the expansion. Expansion is isentropic. Isentropic means vertical. Whether it is vertical upwards or vertical downwards. This is the expansion. Because of the expansion, the temperature also decreases along with the pressure. So 2 to 3 is the expansion that has to be drawn vertical downwards. So because of the expansion, pressure decreases, the temperature also decreases. So 2 to 3 is the expansion. The expansion is the isentropic expansion. Later, the heat rejection. The heat rejection is 3 to 4. That is the isothermal heat rejection. Keeping temperature constant. So keeping temperature constant, the heat is rejected. Okay, keeping temperature constant. Isothermal means horizontal. Whether horizontal forward or horizontal backward. You see the heat addition. Because of the heat addition, the entropy increases. Because of the heat rejection, the entropy decreases. Decreases. That means you have to draw backward. You have to draw backward. So 3 to 4 is the heat rejection. The type of the heat rejection is the isothermal heat rejection. Isothermal heat rejection. So heat entering into the system is drawn like this. Heat entering into the system. This is the heat leaving from the system. So 3 to 4. Afterwards, 4 to 1 is again the compression. 4 to 1 is the compression. Because of the compression, the pressure increases, also the temperature increases. Entropy is constant, means vertical. So you have to draw vertical upwards. You have to draw the vertical upwards. So this is the compression. The compression is the isentropic compression. So it is very easy to draw the TS diagram. So two isothermal process, two isentropic process constitutes the Carnot cycle. So TS, TS, TS. Like that you can remember the Carnot cycle. Each and every cycle it will have its own code that will be easy for the students to remember properly. So the next one is the PV diagram. So while drawing the PV diagram, the basic concept is this. So if the pressure is constant, horizontal. If the volume is constant, vertical. Remaining all process have to be shown curved lines. So first we have to draw, we will start with the heat addition, isothermal heat addition. So you have to locate the point 1. You have to locate the point 1. Then 1 to 2 is the heat addition, isothermal heat addition. Isothermal heat addition. Isothermal. Isothermal means here constant pressure is horizontal, constant volume is vertical. Other than this curved line. So it is other than these two. That is why it is become the curved line. So curved line upwards or curved line downwards. So we will see. I am drawing curved line downwards. Whether logically it is correct or not. We will see. So this is the isothermal heat addition. Isothermal heat addition. So why it is become curved downwards? So the isothermal process. So you can see the isothermal process. You can apply the gas equation from 1 to 2. According to the gas equation, P1 V1 by T1 is equal to P2 V2 by T2. So this is isothermal process. Isothermal means T1 is become equal to T2. Therefore, P1 V1 is equal to P2 V2. That implies PV is equal to constant. That means P is inversely proportional to V. P is inversely proportional to V. Our process is the heat addition. Because of the heat addition, so you take the gas, you add heat. What happens to its volume? Its volume increases. Its volume increases. So because of the heat addition, the volume increases. So if the volume increases, so P is inversely proportional to volume. If volume increases, the pressure will be decreased. The pressure will be decreased. That is why during the heat addition, the volume increases, the pressure decreases. So that is drawn curved downwards. So the first 1 to 2 process is isothermal process, that is curved downwards. So it is drawn. The next one is the expansion, isentropic expansion. So constant pressure is horizontal, constant volume is vertical, other than this curved line. So from 2 to 3, you have to draw the curved line. Curved line upwards or curved line downwards. So this is expansion. This is expansion. Because of the expansion, the volume increases. Because of the expansion, the pressure decreases. So you have to draw the curved line like this. So 2 to 3 is the expansion. The type of the expansion is isentropic expansion. Again it is curved downwards, and the volume increases. At point 2 volume is V2, at point 3 volume is V3. Later, so 3 to 4 is the heat rejection. So the heat addition is drawn. The same logic you can apply for the heat rejection. Isothermal. So constant pressure is horizontal, constant volume is vertical. Other than this curve. So this is other than this. You have to draw the curved line. You have to draw the curved line. I have drawn the curved line like this. So whether it is correct or not. So this is the isothermal heat rejection. Isothermal heat rejection. So isothermal heat rejection, the principle is PV is equal to constant. The pressure volume varies like this for the isothermal process. So that means pressure is inversely proportional to volume. Because of the heat addition, volume increases. So because of the heat rejection, you reject the heat from the system. So because of the heat rejection, then what happens? The volume decreases. Here volume increases, here volume decreases. Whenever the volume decreases, the pressure increases. So we have to draw the curved line upwards from 3. So this is an isothermal heat rejection. So later 4 to 1. 4 to 1 is a compression, that is isentropic compression. Isentropic, constant pressure horizontal, constant volume vertical, other than this curved line. So this is other than this process. That is become curved line. So curved line, compression means volume decreases. Compression means pressure increases. So you have to draw the curved line upwards. So this is the compression. The compression is the isentropic compression. So isothermal heat addition, isentropic expansion, isothermal heat rejection, isentropic compression. So all 4 lines are the curved lines. All 4 lines are the curved lines in the Carnot cycle. So this is why it is drawn downwards, the isothermal heat addition. Why the isothermal heat rejection is upwards. The logics they are shown here. So PV is equal to constant for the isothermal process. That means P is inversely proportional to the volume. Because of the heat addition, volume increases, pressure decreases. Therefore, it is curved downwards. And again, isothermal heat rejection, the opposite happens. So the volume decreases, therefore the pressure increases. Therefore, it is done vertical. So this is a method of drawing the PV and TS diagrams for the Carnot cycle. Thank you.